Thank you for the introduction. First of all, I would like to thank Philippe, Suzanne, Guillaume, and Ingo for organizing this series of workshops, which is very valuable indeed. And then I will present this paper, which is a derivation of the thesis of Ahmed Abura'Ed, who graduated 5 months ago from our large-scale text understanding system lab. Is part of the natural language processing group at the Universitat Pompeu Fabra in Barcelona. Ahmed is in the public, so he will be able also to answer questions. So this is the outline, but I will skip it in order to save a little bit of time as well. So the motivation for our work, so we scientists are overwhelmed by the amount of information that is available to us. We know that scientific papers are published at an incredible pace. And not only that, but scientific databases that have curated records of scientific output are also growing at unprecedented rates. So summarization of scientific texts can help alleviate the problem of scientists having to assess papers that need to be read. So a summary can help you decide whether to read the paper or not, or a summary can help you create your own research. So related work reports are a kind of summary because they summarize the content of several related papers in a narrow domain. And there has been several works approaching the automatic generation of the related work reports, but none of them is similar to the one that we are going to present here. So the related work reports, we know that are an essential part of every scientific publication. In fact, they can be used as to assess the quality of papers, or based on related work reports, your paper may be highly or lower ranked. We know that their function is to provide the necessary background and context for the work to be presented. And we know that scientific related work reports are formed by citation sentences, which will summarize the work of the paper being described. Additionally, obviously, related work reports will contain additional sentences that will probably compare different approaches or compare past approaches with the approach being presented. Sometimes to make the related work report coherent, or a way to organize the related work report is following topic organization, in which the author will say, okay, I will discuss in my related work report these topics, and then for each topic, some papers are described, as it is shown in the example on your right. Okay, in order to evaluate our approach to related work report generation, we have created an annotated corpus that is based on a collection of documents that was carried out by Huang and Kang in 2010. This data set collected by these authors is more or less what we depict on the right. So it's a set of related work sections and the papers which are being referred to in this related work. And we extend considerably this data set by providing machine readable versions of the related work sections, the different related papers that have been cited, and also by adding an additional level of to this structure. This additional level provides citations papers that cite the related paper being referred to in the related work report. This particular level will allow us to study citation-based summarization approaches, for example. Most importantly, our corpus contains agreed human annotations for the relationships between citation context in the related work and sentences, one or more, in the reference papers. And these links that you see in the level 1 are being agreed after human annotation. So the three annotators annotated each of these texts. With respect to the size of the corpus, we have 20 clusters as the one that I am presented in the image, which could be a small number of clusters, but in fact there are quite a number of full papers that have been provided in the corpus, which gives a considerable corpus for testing or training approaches. With respect to the agreement between the notations on level 1, so we have a moderate agreement between the annotators. It must be acknowledged that the task is quite difficult because you have a semantic match approach, and also reference papers contain many sentences. Okay, so in order to summarize papers, what we have two approaches. One is an extractive approach that is based on citations. This is an approach that we have investigated previously in the SysSum summarization challenge. In this challenge, systems or participants are given a cluster which is composed of a reference paper and a set of citing papers. And the task is to produce a summary of the reference paper. And additionally, in the cluster, we are given several gold standard summaries. One of them is the author abstract, then a community-based abstract, and a human summary as well. Also, we are given with links between the citation sentences and the paper that needs to be summarized. So sentences in the paper which need to be summarized. Although this data set is bigger than our data set, we believe that our data set is better curated because it has 3 annotators per paper. Instead, in this data set, there is only 1 annotator. Okay, so our approach to a score sentence to summarization is a sentence that is a system that scores sentences based on internal information from the reference paper and contextual information from the citations. So what we learn here is a scoring function could be thought as regression using a convolutional neural network, and the overview of the system is presented on the left in the image. So basically what we want to do is to each sentence we want to obtain a score for the sentence. And in order to carry out this task, we have 2 neural networks, one which is trained on word embeddings, different types of word embeddings that we rely on, and also on summarization features for the sentence that we want to score, and also for the previous and following sentences. The 2 networks are connected in order to produce a final score. As for the features that we use, the document features are standard features from summarization. Some may be well known, some could be new to our approach, but they have been extensively used in text summarization. As for the context features, what we do is to provide similarity values between the citation sentences and the sentences in the reference paper that we want to summarize. As for the scoring functions, because we don't have obviously a score for each sentence, we simulate this by comparing each sentence in the reference paper with the human abstract, with the 3 human abstracts that have been provided. And we have several ways to compare using quasi-similarity, using the Rouge metric for summarization, and we have different scoring mechanisms. For training, we use the dataset of the SysSum challenge 2018. How we generate, so we use our dataset to generate the related work reports and being able to evaluate. So we use level 1 basically that we want to generate, and we use we summarize each reference paper in level 1 using the level 2 that provides the citation. And in this way, we select a few sentences from each reference paper for the related work report. following the observations that I made at the beginning about topic organization. So in each cluster, we perform latent deleted allocation. So we discover the topics that are being dealt with in these papers. And then for each reference paper, we select the topic that is most representative for that paper. So we start with the paper with most citations and its topic. So we put the sentences of this paper in the reference in the related work report. And then we continue with all the rest of the papers on the same topic. And then once we have reported all the paper, all the sentences of the topic, we continue with the next paper and so on. But obviously related work reports do not have copy and paste sentences from the papers that are being referred to, but authors usually use heavy paraphrasing and summarization strategies to convey the information in the related work report. So we have also studied a citation generation approach using current deep learning methods. So we have trained a series of models using a dataset that we have collected of over 16,000 pairs of title, abstract, and citations from scientific paper. The data has the form that is presented in the first table on the left. We also have produced a filter version of this data in order to reduce the size of the instances and also to concentrate on contributions of the author. So basically, we train a model. So in the right-hand side, you have a model, several models that are trained with the title, abstract, and the citation sentences. And the models are two that we have tried. One is a bidirectional recurrent neural network, and another is a transformer-based architecture. In our experiments, the bidirectional neural network performed better using the filter data. So that's the model that we will use pre-train for our experiments. So the idea now is that for each paper that we want to summarize, we feed the model with title and abstract, and we generate citation sentence, and we put it in the related work section. So results for our experimental framework compares the extractive approach in the beginning with several baselines. The baselines are uninformed baselines. So we use the titles of the papers, the first sentence of the abstract, the last sentence of the abstract, several off-the-shelf systems that exist for summarizing papers. Two unsupervised methods. One is using BabbleNet for semantic matching citations to sentences, and other is using a modification of the Jaccard coefficient to match sentences in the citations to the sentences in the paper. And then several configurations of our networks. The different sub-indices indicate which scoring function was used and which abstract with which type of gold standard was used for that. It can be seen here, so we compare everything with Rouge. It can be seen here that the unsupervised approaches obviously have a good precision, but very low recall. The off-the-shelf systems in general perform poorly, except for LexRank. For the unsupervised system, BabbleNet is particularly good at recall because obviously it's a semantic-based measure that is able to retrieve interesting sentences. And the CNN approach, so the regression model with CNN, is better in terms of Rouge in these experiments. We also evaluate the quality of the related work reports relying on humans. So we evaluate 3 dimensions: responsiveness, how good is this related work report for the paper; linguistic quality, how understandable and grammatical is; and text organization. And we ask 3 evaluators to evaluate each related work report in a Likert scale from 1 to 5. And we can notice that obviously the gold standard is the best. We also evaluate the best baseline, that was LexRank, and our model with and without topic modeling, and the topic model is preferred over not doing topic modeling. So we further, following the observation that sentences in related work reports are not directly cut and paste from the original article. We feed the abstractive system with information from the extracted from the CNN. So we have tested with 1 sentence, 3 sentences, and 6 sentences that are fed into the rewriting system, the best rewriting system. And what we get, we put it in the related word report. Results with Rouge show much better results, so improved performance. So rewriting seems to be a good alternative to generate the related word reports. As a conclusion, we have addressed the problem of reported work generation using extractive and abstractive techniques. We have relied on a corpus, an annotated corpus, to carry out experimentation, and also crawl corpus to train our part of our models. Our experimental results show that the CNN regression approach improves Rouge scores when compared with several baselines, and that further rewriting the sentences seems to be improving the Rouge results. Human evaluation shows preference for a model which organizes the information in the abstract according to topics. Interesting aspects to be investigated in the future, at least this is what I think. So a combined approach to jointly learn to extract and generate and rewrite the sentences. A human assessment of the citation sentences is important to carry out. Conditioning the generation of the citation sentences to the paper where we want to include the related word report should be investigated. And generation of citation sentence based on multiple inputs is, I think, a very interesting topic to address. So I conclude here. Thank you very much. And